So this is a set of limit laws, a little bit different than what's in the textbook, a little more succinct, I thought. So that's why I included this. Basically, all a limit is when you're evaluating an expression or an equation or a value, a function at some point, there should be some limit. If the limit exists, it's going to equal some limit, and then same for another g of x. So it says if this one is the constant, if I take the limit, so if for example, what if y equals 3, the function is equal to 3, and I want the limit as x approaches 0 of 3. Well, it doesn't matter what x is, y is always 3, so that's a constant, right? So that's that constant rule. So taking the limit of a constant, it is the constant. And then most of these are pretty self-explanatory. I mean, it says if you have an identity function, y equals x, and you substitute in c for x, you're going to get that constant, right? Y equals x is what that's asking for. So that's the identity function. It also looks like this graphically, right? Slope of 1, y-intercept is 0. And so whatever x is, that's what y is. And so that's that. And then this is as if you're adding or subtracting two functions. It's just the addition or subtraction of the two limits. And if you're multiplying two functions, it's the product of the two limits. If you have a constant out in front of some function, it's just the limit times that constant. And if you're raising a function to a power and then taking the limit of it, the answer is that limit raised to a power. This works well with radicals too. I'll do one of those. And then if the quotient, if you're dividing, it's equal to the quotient of the two limits. As long as the denominator is not 0, right? As long as that g of x, as g approaches c, that's not equal to 0 because I can't divide by 0 there. Okay, so that's it in a nutshell. I don't think you'll find them too hard. Let's do some examples. Okay, so they gave us a couple of values. Now we're going to use the limit laws to evaluate them. Notice we don't know what the functions are. We only know what those two values are. So this says, see, that's that constant times g of x, which says take 5 and multiply by whatever the limit as x approaches c for g of x is, and we see that's 3. So that limit is 15. Not hard, right? I hope you don't think it's hard. This says to find the two limits separately and add them together. So 2 plus 3 equals 5. This says you take two limits and you multiply them, and that's one of those limit laws. So that'll be 2 times 3, which is 6. And then this is the quotient, and f of x is 2, g of x is 3, so that limit is 2/3. Okay, hope that's not too confusing. So this came from the OpenStax textbook we're using. So I thought I'd do these even exercises just so you had some more examples. So what I'm seeing is they gave us these values, the values of these three different functions at x equals 6. So when they ask us to evaluate a limit, well, this says find the limit as x approaches 6 for g of x minus 1 and f of x. So all we got to do is substitute in the value. So the limit laws, maybe I should step back a little bit. What the limit laws say, if I'm adding and subtracting some values, I can break this up, or some limits. I can just break it up into the separate limits. So that's the limit of 6, limit as x approaches 6 of g of x, minus the limit as x approaches 6 of 1 over the limit as x approaches 6 of f of x. So then because they gave us these values, we just got to substitute them in. I know the limit of g of x as x approaches 6 is 9. And the limit as g of x as x approaches 6 is a constant 1. And the limit as x approaches 6 of f of x is 4. So 9 minus 1 over 4. Well, that's 8 divided by 4 is 2. So that limit is 2. So for question number 110, this is that power function, right? It says take the limit as x approaches, or that power limit rule. Take the limit as x approaches 6 for h of x, and then we're going to raise it to the third power. So what is the limit as h approaches 6? Well, they're saying it's 6. So 6 to the third, and then we divide that by 2. Now I think 6 to the third is 218. You might want to double check my math. And then 218 divided by 2 is 109. And that's what that limit's equal to. And then number 12 is interesting because that's a little different. Here, let me do some deleting. See how for number 12 it says the limit as h approaches 6 of x times the limit as h approaches 6 of h of x. Well, this is just that identity function. If x equals 6, then y equals 6. And then what's the limit as h of x approaches 6? Limit as x approaches 6 for h of x. We see it's 6. 6 times 6 is 36. Having the function, having the what makes this a little bit different is because I've got these, the normal h of x, and they told me what that is, but then they give me another function in there. So you gotta consider that too. And then of course the last one puts a couple of limit laws together, limit properties together. And that says we're going to find the limit as x approaches 6 of f of x, multiply that by the limit as h approaches 6 of g of x, and then we're going to subtract the limit as x approaches 6 of h of x. And honestly, when I'm doing these, I never write this all out like this. I just know I'm going to multiply the two and subtract them. So f of x is 4, g of x is 9, minus h of x, which is 6. So that's 36 minus 6, which is 30. Okay, so the rest of them are kind of the same here. Notice there's a radical, so you're going to substitute in, find the limit at 6 for g, find the limit at 6 for f, and then subtract them, and then take the square root if you can. I mean, if it's a negative number, that would be we wouldn't be able to do that, so the limit would not exist. So now instead of giving us some values, they're giving us graphs to deal with. And so now, and they also are throwing one-sided limits at us. So for number 18, 118, they're asking us find the limit as x approaches negative 3 from the right. Here, x approaches negative 3 from the right, and they're going to add the two limits. So here's f. It says negative 3 from the right, so I think that's negative 3. So as we approach negative 3 from the right, y is approaching negative 2. And the limit as x approaches negative 3 from the right for g of x, well, we see that it's going up to positive 2, and negative 2 plus 2 is 0. See, it's the same thing. It's just they're giving us, the graphs. This says take the two limits and multiply them. So, and this is as we're approaching 0. So limit of f as we approach 0 looks like it's 1. The limit of g as x approaches 0 looks like that it's negative 2. And divided by 3, and of course that's going to be negative 2/3. Okay, here's a power one. So what the limit is f of x approaches 1. Here, let me clean up this graph a little bit so we can see things. So the limit as x approaches 1 for f of x looks like it's probably 2. I don't know. What does it say? I guess it looks like 2 to me. So 2, and then I'm going to square it. I get 4. And this one again, we're going to take the negative 7 times the limit as x approaches negative 7 for g of x. So negative 7 is where right about there, and that's probably 2. And we're multiplying, so negative 14. So I hope that it's not hard stuff. A lot of it's common sense. You're just applying these limits, and this is useful later on. This thinking will go well beyond this, but it's not too bad.